Okay, so for this one, I'm just going to be talking through the example that I gave you on your sheet. So if you have lost or misplaced this, they're available on eLearn as well. But really, like you're adults now, you should be doing this for yourselves and keeping your stuff together. Okay, so when we're looking at sketching something in turning point form, I care about the same information all the time. I care about x-intercepts, I care about y-intercepts, and I care about the turning point. So in order to calculate the x-intercepts, I let y equal 0 and determine what x is. Now, the quadratic formula will always work for these, but sometimes factorising is faster. So I'm not going to go through another example of applying the quadratic formula. I've done that over here. You can see that I've used the quadratic formula. Now, in this case, the reason why I used the quadratic formula is if I look for my numbers that add to equal 12 and multiply to equal 2 times 14 or 48, the factors of 48 are going to be 12, 4, 1 and 48, 2 and 24, 3 is one of them. So if I divide this by 3, I'll end up with 16. 4, I've got that one already, 5, and then I just go through the circle. So there's nothing that fits this, so I can't do anything with that. So, 8 and 6, that still doesn't fit. So there's nothing that I can really do with this. I need to apply the quadratic formula. If one of these fitted, it's faster to factorise, I think, but I remember factorising really well. So keep that in your little pocket. Okay, so the next thing, after you've calculated your x-intercepts, is you calculate your y-intercept. Now, this by far is the easiest one. You just need to substitute when x is 0 back into your original function. So here, I let x equal 0. I substitute it back in. I work out that it's 14. Now, I could have looked at that straight away and seen because it's always the constant on the end. So here, just by looking at the formula, it's going to be 14 because everything else zeroes out. Now, the next part that I need is the turning point. Because everything's expanded in standard form, we can use our formula to find the turning point. So in our example, A equals 2, B equals 12, C equals 14. I state my formula, I substitute everything back in, I get an answer. So the x-coordinate of the turning point is going to be -3. I then put that back in to find out what y is going to be. So y equals, and I put the -3 back into my function, I get -4, so there's a turning point at -3, -4. So now I've got all of the important information that I need. Next thing that I'm going to do is start my graph. So like I always say, you should just do a rough sketch before you do a nice one. So I just throw my axes to look kind of even to start off with. I'm going to label my y-intercept on first, which is going to be 14. And then I'm going to label my x-intercepts on. So for this one, it's going to be at -1.5 and -4.4. So down here, 1, -1.5. Now that 8's actually going to round to a 7 to a 9 if I go to 2 decimal places. And then the other coordinate's going to be over here at -4.41 if I round it to 2 decimal places. So because they're the only 2 points on my axes, I try and make it as exact as possible, but it doesn't have to be perfect. The next one that I'm going to put on there is our turning point. So that'll be halfway between these two at -3, and then I'm going to use this to help me scale for this axis down here. So you can see that this has gone up, about 14 spaces. So I'm going to estimate that 4 or -4 is going to be about here, meaning that's my turning point. So now I've got all of my coordinates. I've got my y-intercepts, my x-intercepts, and my turning point. Next thing to do is just join them with a line. Whee! Just like that. Okay, before we finish off, you need to state your domain and range. Now, this should be a habit for every graph that you draw. So the domain is your possible x values. So I like to start off by putting the x in and the y for range. Now, looking at this, I can see that if I put in an x value over here, I'd get something over here. If I just kept going off the screen, I'd always have an x value in this direction, and I'd always have an x value in that direction. So This, for our domain, is going to go from negative infinity to positive infinity. But this is going to be different for our range. So you can see down here that the lowest value that y can possibly be is negative 4. Below that, our graph doesn't exist. Now, if I put in negative 3 into this function, I get negative 4 as an answer, meaning that it's including negative 4. It does actually touch negative 4. It's the lower point that it touches. Okay, and then this function continues forever going up. So it continues forever the positive infinity direction, and remember, you can't touch infinity. It's really big, and every time you get even close, it gets even further away.